Hello everyone, this is another video in the quantum mechanics lecture series, right? Here should be question number 20. Okay, question number 20, that is a system is known to be in a state described by the wave function psi theta phi is equal to 1 by root 35 y40 y60 plus 2 y63. This is written in the form of spherical harmonics, that is ylm. Okay, so this one is L, this one is M. Okay, the probability of finding the system in a state with m is equal to 0 is probability of finding the system in a state with m is equal to 0 is how much, right? M is equal to 0 is how much. So we have to find which parts in which mm, like which terms are L is m is equal to 0. See, this is LM, m is 0 here, m is 0 here. This is m is 3, so we won't count that. So how will we calculate the probability? So probability for m is equal to 0. Probability for m is equal to 0 is what? What summation c for m is equal to 0 square, isn't it? This is it. For which terms? So like m is equal to 0. They are coefficients. So see, this one is 5 by root 30. First term is 5 by root 30 whole square plus what? This one is what? This is 1 here. So 1 by root 30 whole square. So 1 by root 30 whole square. Okay. So this will be your what? 25 by 30. Should be your 25 by 30 plus 1 by 30 plus 1 by 30. So that will be what? The answer will be 26 by 30. That is what? 13 by 15. If you check the options, is it there in the options? And check, is it there in the options? Yeah, it's there. It's option D, right? Easy question, right? Yeah. This is coming from spherical harmonics. Okay, spherical spherical harmonics. Okay, let's go to the next question. The commutator Lz YLM theta phi, where Lz is the z component of the orbital angular orbital momentum. YLM theta phi is the spherical harmonics is, right? So what is it saying? Commutator Lz YLM commutator Lz YLM theta phi YLM theta phi, right? That is equal to what? That is equal to Lz YLM theta phi Lz YLM theta phi Lz YLM theta phi minus YLM theta phi Lz. Okay, Lz. All right. Yeah. All right. Now Lz y like we have to take a psi here, right? Psi, so that psi will be here. Psi will be here. Right? So now see. Um, Now Lz psi will be what? What is the eigenvalue for Lz? Lz is minus IH cut. Lz is minus IH cut del by del phi. Okay. Minus IH cut del by del phi, and this is your psi. Okay. So what can I write it? For example, psi is your what? Psi is your e to the power. We can write it as e to the power im phi, isn't it? We can write the wave function as e to the power im phi. So if we write it here, minus IH cut del by del phi of minus IH cut del by del phi of A e to the power im phi e to the power im phi. Okay, so what it will become, minus IH cut into im into A into e to the power im phi, isn't it? The power im phi. Okay, so this one becomes what, II is minus 1 is there already, so this becomes mh cut A e to the power im phi. So we took a value and we checked. Okay, and see, this is your eigenvalue of what, Lz, isn't it? So Lz will be what, Lz is mh cut. Okay, Lz is mh cut. Hmm. This part will become 0, so only this part, for Lz the value will be mh cut. Okay, so the answer will be what, mh cut. All right. Yeah. So the next question, uh, this was what, question number 20, 20, 21, 21. Question number 22. Question number 22. Let psi NLM denote the eigenstate of a hydrogen atom in the usual notation. The state, this one is an eigenstate of. Okay. See how to solve this one. See, you have to check what do you have to check to solve this type of question. Hmm. First, you take time. You take 1 minute and try to solve it. Then I will tell you. This is an easy question. There is nothing in it. Otherwise, you can pause the video. See how to know this type of questions. See, this is your what, N L M. It's written in the form of NLM. Okay. So, if like it's written in the form of what, NLM. So, how to know what are the conditions? What are the conditions to know that this is an eigen, like which option is correct? Think of it. I gave you one hint. This is N, this is L, this is M. Hmm. Think of it. Okay, see, we have to just check n value. N value in everything is what, 2. If you can see, n value is 2 everywhere, isn't it? N value is 2. So what? For n value, what is your en? We know energy eigenvalue is what, minus 13.6 by n square. Okay, electron volt. So for n value, if n value is constant everywhere, then En is conserved, right? Or we can say it's an eigenstate of En, right? Or we can say Hamiltonian, isn't it? Energy is what, so n is also called Hamiltonian. So if n is same everywhere, we can say this is an eigenstate of Hamiltonian. All right. Now next is, if L value is same, if L value is same, we will be able to say this is the eigenstate of L square. But see, if L value is same everywhere, is it L is 0 here, 1 here, 1 here, 1 here? No, L value is not same, so this is not an eigenvalue of L square. Now M value, M is, this is 0, this is 1, this is 0, this is minus 1. So M value is also not same everywhere. So M is not same. M should be same, but M is not same, so it's not also an eigenvalue of what, Lz. If M is same, it's an eigenvalue of Lz, which is not correct. All right. So you can see only one option is there. That is only Hamiltonian is like, it's an eigenstate of only Hamiltonian. So you can see the answer will be option B. Alright. You can write it again. If n value are same, the eigenstate of what? Hamiltonian. If L value are same, eigenstate of L square, and if M value are same, then eigenvalue of Lz. Okay. Next question. Let psi0 denote the ground state of hydrogen atom. Choose the correct statement. Okay. So hydrogen atom ground state is what? 1 psi 100 is equal to how much? This is question number, I think, 23. Yeah. 23. Question number 23. Yes, psi 100, how much? What is the ground state of hydrogen atom? 1 by root over of pi a naught cube e to the power minus r by a naught. Okay, this is the ground state of the hydrogen atom. So if I apply these options, first let's see option A. Option A is what? Lx Ly. Option A is Lx Ly psi 100 psi 100. So if I apply it, what is Lx Ly? Commutator I h cut Lz, isn't it? Simple. So I h cut Lz psi 100, isn't it? Psi 100. Okay. Okay. Now Lz, I can write what? Lz is what? Minus I h cut del by del phi. Okay. Minus I h cut del by del phi of psi 100. Psi 100 is this one. Just put it there. Just put the value of psi 100. This is 1 by pi a naught cube e to the power minus r by a naught. Can you see any phi term here in the ground state of hydrogen atom? There is no phi term here. So del by del phi of this one will be what? 0, isn't it? So the answer will be 0. Okay. So I think this option A is correct, isn't it? Option A is correct. That is Lx Ly. That is Lx Ly. Lx Ly psi naught wave function is equal to 0. Alright? Yeah, this is also. Yeah, this is question number 23 now. 24. See this question. An atomic state of hydrogen in is represented by the following wave function. This one. The quantum number of the state R. The quantum number state. See, this is the question of hydrogen atom. See, psi r theta phi is given this one. So quantum number of the state. Okay. So see, how to know? See, psi r theta phi is equal to 1 by root 2 is equal to 1 by root 2 a naught 1 minus r by 2a naught, okay, e to the power minus r by 2a naught cos theta. Alright, 2a naught cos theta. Yeah. So now see this one na, this one here. This one will tell me what is the n dependence. Here n is 2. Okay. R by whatever there is, that is your n. So n is equal to 2. Alright. If n is 2, then L will be what? Always less than 2. Okay. Always less than n. N is what? Sorry. L is what? L should always be less than n. So L can be what? 0 or 1. Isn't it? L will be your 0 or 1. Okay. So if L is 0 or 1, then its ml values will be what? It's ml, for 0 the ml value is 0. Ml values, right? Quantum numbers are asked, NLM are asked in this question. So for L is equal to 0, ml 0. For L is equal to 1, what are the eigenvalues? Like, sorry, what are the ml values? Minus 1, 0, 1. Okay. So this is the answer. If you see n is equal to 2, let's see, n is equal to 2. Yeah, this one is n is equal to 2. Um, L is equal to 1. Yes. M is equal to 1. This is right. Okay. N is equal to 2. Yeah. L is equal to 1. M is equal to 0. This is also right. Okay. This one is not right. Like, okay, this one is not. This one cannot be the answer. This one is not the answer. So two options are coming correct. So I think it's an MSQ question. Okay. Yeah. Clear? Next question. The radial wave function of electrons in this one is in hydrogen atom is this much. Find the probable values of R. Most probable. So this type of question we had done in the previous class. Okay. So probability is what? PRDR. Okay. PRDR is equal to how much? Psi star psi dV. Right. So if I write it here, it would be I have to multiply it twice. 4 by A naught Q. Okay. Exponential minus 2R by A naught. It will become, isn't it? 2R by A naught. And dV I can write as, tell me, dV can be written as 4 pi r square dr, isn't it? 4 pi r square dr. Okay. Yeah. So this is your probability. For most probable value, what will I do? I will do dpr by dr is equal to 0. Okay. For most probable value of r, isn't it? So dpr by dr, question number 25. dpr by dr is equal to 0. So you just have to do what? Take the derivative, the whole this one is equal to 0, isn't it? So if I take the derivative of this one, see, the constants will like multiply and go to the other side and become 0. So only the main part will be there. So if I take the main part, so it will be 2r minus 2 by a naught r square, and this one will be e to the power minus 2r by a naught is equal to 0. Okay. So this whole one will also go to this side and become 0, isn't it? So what is left? 2r is equal to 2r is equal to minus 2 by a naught. 2r is equal to minus 2 by a naught r square. Okay. So this one is r. This one is r cancelled out. So this is your 2 2. Okay. So r is equal to how much? Right. Oh, sorry. R is equal to a naught. Okay. So yeah, this is our answer for it. All right. So these are some of the questions related to hydrogen atom and spherical harmonics. Okay, I hope you understood. And these are very easy questions. Okay, we'll solve more advanced questions next class. Okay, that's it for today. Thank you.